Hello and welcome to another exciting episode of Maths with Mr. Thompson. Today we're going to look at something which is an important part of the linear algebra topic that we've been focusing on. We've looked at drawing lines given equations. We've looked at the algebra method of solving equations. And this video is all about how to form the equation if you're given a word description of a real life situation. So I've got three examples for you. I'm going to talk you through each of them one at a time, and hopefully by the end of it should be quite apparent how to develop the same method that's going to work for us every single time. So here's a pretty standard situation. A tradesman charges $35 for a call out and 40 hours per actual hour of work. Well, let's have a little think about what our graphs tend to look like. The sort of graphs we've been working with start with a starting value here, a plus c for y equals mx plus c, and a gradient here. So if you just have a sort of think about it, that there would be a starting figure. That there looks like a starting figure. So that's my plus c part. Over here, this gradient is a rate of change. It's a rate, something that changes, that we charge, that increases, as we go along. And so there's this per hour. That's a rate. So if you think about y equals mx plus c, and what these things mean, well, what they mean is that there is the starting figure, and that there, the gradient, is the rate. So by thinking about it, our cost is going to equal the rate, which is $40 times the number of hours, plus our starting figure, which is 35. Oh, excuse me. Yeah, 35. So you might want to abbreviate that to C equals 40H plus 35. Okay, I'm just taking out the dollar signs for quickness. So that's it, simple as that. Y equals mx plus c, the gradient is the rate, and the c is the starting point where we start off from. So here's another one. We've got an electricity company, power company, and the numbers are a little bit more challenging this time, but still no difference. I mean, we look at our graph again, this time we've got 75.50 is the starting point. And the gradient this time it's not $6, it's $0.06, that's about 6 cents per unit. So let's just remember that, that's the rate of change. So the cost is going to be 0.06 times the number of units plus $75.50. Okay, so make that a little bit tidier. Y equals 0.06, I'm going to call it U, plus 75.50. Okay, the starting figure is my plus C, and that hourly rate, the gradient, the rate is what goes there. Okay, Y equals mx plus C. One last one. This is a standard one, of course. You've got your printers are actually remarkably cheap, and then you find out why as soon as you go and trying to buy an ink cartridge for it. Basically, with this one, it's $100 to start with, which is reasonable, but it's a very steep curve for costs up, and basically you get a gradient of $35 there. So again, my cost is going to be my initial outlay of $100 plus $35 times every single cartridge that I use. So I'll just tighten it up. So Y equals, and my, let's not call it Y, let's call it cost, is 35C plus 100, and that's a value in dollars. I suppose the only thing that you might get confused about with these ones is that the first number you tend to see, in this case the 100, is the last number you write down in the equation. They tend to say, here's the starting figure followed by a rate, and when you write it down, it's actually the first number they give you that gets written down last. It's the second number that appears first in the equation. Okay, so that's the standard method for finding the equation given a word description of a real life problem.